All right, so here on worksheet 2, how'd number 2 go? All right, the graph below represents the velocity v in feet per second of a particle moving along the x-axis over the time interval from 0 to 9 seconds. Number 1 wants to know, at t equals 4 seconds, is the particle moving to the left or to the right? Well, if the velocity is positive, right. If the velocity is negative, left. So at 4 seconds, there's the velocity. It's positive, so the particle must be moving to the right. We okay with number 1? All right, number 2, over what time interval is the particle moving to the left? Well, it's going to be moving to the left when the velocity is negative. The particle moves to the left when its velocity is negative. So on this particular graph, on this time interval, where is it negative? Negative when it moves to the right of 5, and it remains negative until they stop measuring. So from 5 to 9. Not exactly at 5, right? But as soon as it's past 5 to 9. We okay with number 2? Number 3, at t equals 4 seconds, is the acceleration of the particle positive or negative? All right, now this goes back to the idea of the relationship in a graph and its derivative. At t equals 4 seconds, our graph decreasing, isn't it? It's positive, but it's decreasing. Here's t equals, so the graph is decreasing. If a function is decreasing, its derivative is negative. So if the velocity is decreasing, its derivative, acceleration, is negative. So a of 4 is negative because the velocity is decreasing at t equals 4. And then a little reminder, f prime of x is negative if and only if f of x is decreasing. Number 3 makes sense? It's a lot of your writing, so does that make sense to you now? And it gets confusing sometimes, doesn't it? You're switching from looking at positive or negative to looking at increasing or decreasing, and it's easy to get them flip-flopped. And number 4, what is the average acceleration? All right, now, acceleration is the derivative of velocity. Acceleration is the rate of change of the velocity. So what is the average rate of change of this graph is what this question is asking. Okay? And the average rate of change we can always find using the slope formula. y2 minus y1 over x2 minus x1. It's not going to be y's and x's anymore, is it? But it's the same idea. Okay? So the average acceleration of the particle interval from 2 to 4. Show the computations that led to your answer and indicate units of measure. All right, so the average acceleration from 2 to 4 is the average change in velocity. I should have said rate of change. No, average rate of change in velocity from t equals 2 to t equals 4. So, slope formula. So the average acceleration equals y2. That'll be v of 4 minus y1, v of 2, over, it's not x's, it's t's, but t2 minus t1, 4 minus 2. Yes? I would, because like we've talked about before, when you know, you better put it on there. Because when you don't know, you're not going to, and you're hoping to bluff them, right? They're very hard to bluff, by the way. Y'all can figure that, right? But it's the change in velocity in feet per second divided by change in time in seconds. The only reason I'm writing that down is to help me get my units at the end. Okay? Well, v of 4 is 6. V of 2 is 9. So that's 6 minus 9 over 2. So that's a negative 3 over 2. And then it's feet per second, or feet per second squared. And I see some of you writing now. So does that make sense to you now? Okay, we ready to move on? All right, number 5. Is there guaranteed to be a time t in the interval from 2 to 4 such that v prime of t equals negative 3/2 feet per second squared? So in other words, we found that the average acceleration from 2 to 4 is negative 3/2. Does the acceleration have to equal that somewhere between 2 and 4? You'd think so, wouldn't you? But no. The mean value theorem does not apply since v of t is not differentiable on that interval. How do I know that? That v of t is not differentiable on the interval from what to who? 2 to 4. There's 2. There's 4. How do we know that there's at least one place where the derivative of that function does not exist? Because there's a cusp. There's a sharp turn. Okay? And that means that the hypothesis of the mean value theorem, which is what we wanted to say, right? That at some point, the acceleration has to equal the average acceleration. That's what we want to happen, but it does, and it might. It might. But the question is there guarantee? And the answer is no, because the function's not differentiable everywhere. Okay, so we happen because the mean value theorem applies. Functions can be differentiable. So number 5 makes sense. Number 6, is this the last one? At what time t is the given interval, no, at what time t in the given interval is the particle farthest to the right? And explain your answer. All right. Think about what the graph shows us. On this interval, the particle starts off with a positive velocity, which means the particle is moving to the right. So don't really worry about what the graph looks like so much, but pay attention to the fact that the velocity is positive from 0 to 5. So the particle's moving to the right the entire time from 0 to 5. Then at 5, the velocity is 0, so it stops. And then the velocity is negative. And what's happening to the particle when the velocity is negative? It's moving to the left. So if we graph the position function, that's not right. If I just graphed the motion of the object from 0 to 5, it's moving to the right, then it stops. And then from 5 to 9, it's moving back to the left. And I don't really know how far, right? It may go this far, I don't know. But it's going back to the left. So doesn't its farthest movement to the right have to be at 5? Now you got to explain it. So the particle is farthest to the right at time t equals 5 seconds. The velocity is positive from 0 to 5 and negative from 5 to 9. So at t equals 5, the particle changes from moving to the right to moving to the left. Thus, its farthest position to the right is at t equals 5. Or a function has a relative maximum where it changes from increasing to decreasing. That is, where its derivative changes from positive to negative. So we can ignore the whole motion talk and treat our graph as the derivative of the position function. Okay? And where do maximums occur? Where the derivative changes from positive to negative. So the maximum position had to occur where the derivative changed from positive to negative.
You said all the points that were available, and you just said T was 5, so we got points for we can positive. You have to mention that.
I think that probably depends on how easy it is for them to get 9 points out of the problem. Because I think that would be okay. You know, but you know, I hate to say I don't trust them, but I don't trust them because every time, and I've been going to these things for years, the graders always talk like, and some of y'all have heard them, as if they're just doing everything they can to give you a point, and I've not seen those results. I've just not. So I think they would say yes, and then I think I would say, I wonder if they really will. Okay? I know, because you can't write a book because you won't finish the test. So you're right. So that's a quandary because I don't know. I really don't. And I know what they say, but okay. All right, so does that help for number 2? Number 3. So we've done motion. We've talked about motion using data from a table and using a graph. And really, weren't those two methods very similar? They were either looking at numbers in a chart to see is something increasing, decreasing, positive, negative, or they were looking at the graph of it and seeing if something's increasing, decreasing, positive, negative. Okay? Now, analytically, a particle moves along the x-axis so that at time t, its position is given by, and then they give us the position function. X of t equals t cubed minus 6t squared plus 9t plus 11. At t equals 0, is the particle moving to the right or to the left? Okay, we've got a lot of work to do here, don't we? Because the particle's moving to the right if its velocity, if its derivative is positive. It's moving to the left if its velocity, its derivative, is negative. So here we go. There's our function. I take its derivative. I called it x prime of t and v of t, and that covers me with the graders because now no matter which one they're looking for later on in the problem, I've said those things are equal, so I should be able to use either one. Okay? Once I get the derivative, I factor out a 3, and then I factor that trinomial. And I don't know if I'm going to need this, but while I was in the derivative taking mood, I went ahead and took the derivative of the velocity. So I'm calling that x double prime of t. I'm calling it v prime of t. I'm calling it a of t. And the easiest place to take the derivative of the velocity from is right there, isn't it? So I took the derivative of the velocity, I got that, and then I factored it. So I can do analytically anything I need to do now. I can do first derivative test, second derivative test. I should be able to find maxes and mins. I should be able to tell where the position is increasing, decreasing, right? I've got all the information. Okay. So the question is, at t equals 0, is the particle moving to the right or to the left? All right, so find your velocity, put in a 0 for t. So that parentheses would be negative, that parentheses would be negative. Negative times negative is positive. Positive times 3 is positive. So at t equals 0, the velocity is positive. Therefore, the particle is moving to the right. Okay with number 1? Number 2. At t equals 1, is the velocity of the particle increasing or decreasing. Okay, now, for the velocity to be increasing or decreasing, we need to know the sign of its derivative, don't we? Okay? If its derivative is positive, then the velocity is increasing. If its derivative is negative, the velocity is decreasing. So I had already found the derivative of the velocity, so all I got to do is put a 1 in there. 1 minus 2 is negative. 6 times negative is negative. So at t equals 1, the velocity is decreasing since, and you don't have to write every possible notation you've ever used. You've spelled it out that they're all equal to each other, so you should be good no matter which one you use. So I'd probably use a of t is negative. And then this is a note from me to you. A function is decreasing if its derivative is negative. Okay? Do make sense? Number 3, find all values of t for which the particle is moving to the left. It's moving to the left whenever the particle is moving to the left whenever the derivative of the position function is negative and whenever the velocity is negative. So I kind of explained that first. If v of t is negative, then the particle is moving to the left. Now, in a note from me to you, notice they didn't say I had to explain it. Well, I assume they mean that. If they don't say to explain it, I don't have to. Okay? So for me to you, it's the first derivative test. If we look back here at the first derivative, the velocity, okay? Let's see, can I get all this on the screen at once? What number am I doing, 3? Yeah. All right, so wouldn't we have critical numbers? I haven't written any of this out, but wouldn't we have critical numbers at 1 and at 3? Okay? And so, let's see. You know, second derivative test might actually be easier. Well, no, let's stick with this. All right, so let's see. To the left of 1, we would have a negative number here, minus 3. That's negative. We would have, wait a minute, I shouldn't say that right. A number to the left of 3 minus 3 is negative. A number to the left of 1 minus 1 is negative, so our first derivative is positive there. Then let's go between 1 and 3. Okay, so like a 2. If it's 2, that one's still the first one's still negative, but the second one's positive. Now my velocity is negative. Let's go to the right of 3. That one will be positive. The second one would be positive. The velocity is positive. So the velocity is negative between 1 and 3. Okay? Make sense? All right. Number 4. Find the total distance traveled by the particle over the time interval from 0 to 5. So we could do it the same way we did yesterday. To find the total distance traveled, find the position at the end points of the intervals at which the point is at rest. So we started at 0. We know that we have critical numbers where the velocity equals 0 at 1 and at 3. Okay? So those are the resting points. The velocity equals 0 at 1 and at 3. So find the initial position, x of 0. Find the position at x equals, or at t equals 1. Find the position at t equals 3. And then they told us to start at 0 and they told us to end at 5, didn't they? So find the ending position when t equals 5. And then, and I didn't write all this out, but just go back up to your position function and figure out the position. Figure out what x of t equals at 0, 1, 3, and 5. Okay? And I got, think I'd learn how to use this by now, wouldn't you? I don't know what's going on.
Don't touch the bottom.
But I'm supposed to be able to touch the bottom.
Oh, just hold it.
I've got to. It's not at the bottom. I've got to do it.
Well, you don't have to do it.
Because look, if I extend.
Oh!
So, when t equals 0, the position is 11. When t equals 1, the position is 15. T equals 3, position is 11. T equals 5, position is 31. So, the particle moves 4 to the right, from 11 to 15. That's 4 to the right. And then from 15 to 11 is 4 to the left. And then from 11 to 31 is 20 to the right. So 4 plus 4 plus 20 is a total distance of 28. Not 32. It is 28. Whew. Any questions? All right. We have more to do. Let's take a look at worksheet 3. I'll help you get started on this one. All right, understand the relationships among velocity, speed, and acceleration. Now, that last worksheet, we worked quite a bit with the relationship between velocity and acceleration. But we need to work speed into the mix. All right? So, speed is the absolute value of velocity. It tells you how fast something is moving without regard to the direction of movement. And we knew that. Number one, what effect does the absolute value have on numbers? Well, it makes all numbers non-negative. Don't say it makes them positive. Does it make 0 positive? No, the absolute value of 0 is not positive. Okay? It makes them non-negative. If a number is negative, its absolute value is positive. The sign changed. If a number is non-negative, 0 or positive, it is equal to its absolute value. No sign change. Okay? So be careful. I mean, that they're not going to ask you on an AP test, right? But be careful and don't just say that absolute value turns everything positive or that it changes the sign, because it doesn't. Okay? What effect does taking the absolute value of a function have on its graph? Well, if we had a graph that looked like that, and we took the absolute value of it, guess what would happen to that negative part? It'd flip up here. Okay? So taking the absolute value of a function will cause any portion of its graph that is below the x-axis to be reflected across the x-axis. So if you had the graph of velocity and part of the velocity was negative, do you know what the graph of speed would look like? Yeah, any part of the graph that's negative for velocity, to get the graph of speed, just reflect the negative part in the x-axis, and you'll have the graph of speed. Okay? And now the work begins. For each situation below, the graph of a differentiable function giving velocity as a function of time t is shown where 1 is less than or equal to t and t is less than or equal to 5, along with selected values of the velocity function. In the graph, each horizontal grid mark represents 1 unit of time, and each vertical grid mark represents 4 units of velocity. For each situation, plot the speed graph on the same coordinate plane as the velocity graph and fill in the speed values in the table. Then answer the questions below based on both the graph and the table of values. So, and if you look through the worksheet, you'll have a situation 2, a situation 3, a situation 4, and then when boy, it'd be really nice if you had some conclusions, okay, based upon what you've figured out with these situations. They're trying to guide you to certain conclusions. I'll do. All right, so we have the velocity graph. Now, not just of tremendous importance, but 1, 2, 3, 4, 5, 4, 8, 12, 16. And the reason I say that is because they give us the table of values. Okay? So if you forget, and they told us the way that our axes were set. Forget, it's table of values right here. So look what the velocity is. It's 1, then 2, then 4, then 8, then 16. It's always positive. Doesn't that mean that the speed is the same as the velocity? The velocity is always non-negative, so it's equal to the speed. So this velocity graph is also the speed graph. And to get the speed at any individual time, it's just the absolute value of velocity. So it's 1, 2, 4, 8, 16, isn't it? Isn't it amazing how I always work the easy ones with you? In this situation, the velocity is positive or negative? Positive. And is it increasing or decreasing? Increasing. Now let me ask you a question. Could you tell both those answers simply from the graph? Yes. Could you tell both those answers simply from the table? Yes. Because velocity is, well, we said it was increasing. We know acceleration is positive, right? If a function, so now think of it this way. Think of this graph as your function. It's increasing. Everywhere it's increasing, its derivative is positive. Positive derivative means increasing function. Increasing function means positive derivative. Since the velocity is increasing, its derivative, acceleration, is positive. Okay? By examining the graph of speed and the table of values, we can conclude that the speed is increasing. All right. At this point, I'm going to leave the rest of worksheet 3 to you. Let me give you your next one. On worksheet 4, at the top, you should be able to answer those from worksheet 3, I believe. Okay? And then, and I like this, before number 4, it says there are 3 ways to use an integral in the study of motion that are easily confused. Watch out. All right, so we did 2 modules about integrals. Hopefully you remember what integrals are/do. That may help you figure out the rest of this. So, get worksheet 3 and worksheet 4. completed.